Hi, everyone. As Alex said, my name is Nicholas Krusten, and I'm here to sort of share some of my excitement about Jupyter, the artist formerly known as IPython Notebook, and how to make it even more magical than it already is with its sort of cell magic extension system. So just a little bit about me. I was a sort of first employee at a Montreal-based startup called Datacratic. We were founded 10 years ago. We're a venture-backed company, and we're democratizing machine learning with our machine learning database, which I encourage you guys to check out if you're intrigued at mldb.ai. And Jupyter is a sort of shipped part and parcel with MLDB. It's sort of the main interface that we ship for our database, and sort of how I learned to love it for data analysis, and is basically pervaded sort of the way I approach Python in general. So just so I get a level set, you guys know a little bit about me. Who here uses the Python REPL on a daily basis at work? Okay, and who here uses IPython on a daily basis at work? And who here uses Jupyter/IPython Notebook? Okay, awesome. And so who here comes to Python from sort of like the web development side of the world? From like the scientific Python side of the world? Some other part of the world? Awesome. Okay. So hopefully there's something in this talk for everybody. So just a little bit about Jupyter, so everyone kind of knows. A bunch of the talks that were given here were either the slides were either generated from Jupyter, or just like I'm about to do, the presenter basically just showed a Jupyter notebook. So basically in the beginning there was the Python REPL. People could sort of type Python code, execute it, get their answers back in real time. That's neat. It lacks a bunch of stuff. Some people got together and built the IPython project, which is still sort of console-based, had auto-completion, much more sort of friendly console-based environment. And then the next level of development after that was the IPython Notebook environment, which was just a full-on web interface to Python. And it became so popular that people actually wanted to plug different languages into it. So there wasn't just Python. You had the IPython Notebook with like an R backend or a Julia backend. And so the IPython Notebook project has been renamed Jupyter. So now IPython is sort of just the Python backend for it, and the front end is Jupyter. So that's why I'm going to be referring to it as Jupyter, although I have to wean myself off calling it IPython Notebook. So very brief introduction to Jupyter. You basically just launch it with a command line, Jupyter Notebook, and it turns on your browser for you. And what you get here is essentially a typical sort of notebook-style interface with cells. So each of the little blocks that you're going to see on the screen behind me here is a cell. And so, first things first, obviously, you can run Python code in Jupyter. So I got this little code cell here, print hello world, and I hit Shift-Enter, and it executes that. So that's cool. And then the thing that takes a little bit of getting used to is that objects and functions stick around from cell to cell. So I can define a function here, it doesn't do anything, and then I call it here, and there we go. And so I can modify my function up here, and I can click back down here, and it executes again. So this is not particularly fancy. And inspecting objects is pretty easy too. I type import requests, and I type request question mark, and I get this little sort of frame that shows up at the bottom, so I can sort of look at the doc strings and stuff. So it's a nice kind of web-based upgrade to what most people would be used to in a shell. You can see that I've actually typed a bit of actual text here. You've got some links. So some cells are Markdown cells. You can double click on this cell here and type some Markdown. You hit Shift-Enter, and it actually renders. And you can sort of switch back and forth. There's a keyboard shortcut. You can select a cell. Hitting Y makes it a code cell. Hitting M makes it a Markdown cell. And Shift-Enter renders it again. So that's like IPython Notebook in 2 seconds. So now I'm going to show you what this talk is about, which is cell magics. So not all cells are created equal. Any line in a IPython Notebook, in a Jupyter Notebook, that starts with a percent or a double percent is not a normal sort of a Python cell. They're magic. That's what they're called. I'm not making it up. So I'm going to show you a really simple one to sort of get warmed up. It's a bit of a meta magic. It's called LS magic. And so when I execute it, it's going to show you all of the available magic that's built in to IPython Notebook. And so there's a whole bunch of them. I'm obviously not going to go through all of them, but this is sort of what's available to you, and I encourage you to read through it. If you just type %magic, you'll get the little documentation pane that will show up, and it'll tell you all about all of the different things you can do. So the sort of one that everybody uses first, because it's really easy, is time. So if you go %time and then print do you have the time, it'll actually execute the Python code print, do you have the time? And then you get a little couple lines at the bottom, which tell you how long it took to do that. It took about 36 microseconds, which is good. And so this is basically a good example of what's called a line magic. Percent time, everything for the rest of the line was essentially handed over to the time magic, which basically chose to interpret it as Python, executed the code, and then printed out some extra information. So you can think about it a little bit like a Python decorator. The next cell here is a cell magic, and you can tell that because it starts with a double percent sign. So a double percent sign will essentially eat the rest of the cell and treat it with whatever magic properties you have. So if I execute percent time it with some little loop here, think about it for a second, and what it does is it runs this cell a million times and then gives you sort of a little bit of performance information. So if you're just running little snippets of code, you want to see, does this run faster than that? You'll often see this in Stack Overflow questions and answers. People will compare essentially using this. So those are examples of how you can kind of spice up your Python code just a little bit with a bit of magic. But the next magic I'm going to show you, %% bash, is completely different. Here, %% bash is the cell magic that says essentially the rest of the text from this cell will be executed in a bash shell. So here I just did a curl on localhost 5000. I'm running the HTTP bin Python project, which basically is like an echo for HTTP clients. So I actually used curl, and it ran, and I got my C error was down here, and it dumped the output here. So this is pretty cool. From my IPython notebook, I don't have to just run Python. I can run bash. And you can install extensions for running R and all sorts of other languages, which I'm not going to get into. So already, IPython Notebook is starting to feel kind of cool, right? You don't have to pop in and out of the shell to do certain things that might be a little more complicated to do from Python. So that's basically the first big idea for this talk, is that Jupyter cells are not just for Python. If they contain cell magic, you can execute code from a whole bunch of other environments, including bash. That's the kind of a first neat thing to know about. So turns out you don't have to actually just use the built-in cell magics. You can download magic from the internet and install it. And so, for example, I've installed an extension called IPython SQL. So I'm going to use some magic to load some magic, the loadx magic to load SQL. So it's already loaded because I practiced this talk, but this is how you would load it if you wanted to do it from scratch. And so now we have access to the sort of %SQL. And this basically turns the rest of the cell into an SQL client. So to the extent that you would sort of pop back and forth between like a terminal running, PGS or PSQL or some sort of command, some sort of client for your SQL library, you can now intersperse sort of interacting with your database and executing Python code inside the same environment. And the major difference here is that you don't have to deal with quotes, triple quotes, and stuff. You can sort of type raw SQL. So as a quick demo, the first time I execute it, it's going to take a SQL Alchemy compatible connection string. So here I'm going to connect to SQLite://, which is going to be an empty in-memory SQLite database. So if I execute that, I'm now connected, and I'm going to load up this very simple data set about how many Stanley Cups each hockey team has won in the top 5. So I'm going to execute that, and now I've essentially inserted this data into my little database, and I can run select statements. So here I did select star from hockey, ordered by Stanley Cups won, limit 3. And it gives me this little table. Now, a bunch of people have used Jupyter in talks so far, and no one has kind of been amazed when this little table shows up. But I was a little bit surprised because every example I've shown above in this notebook so far has had text, right? It's just, you print something and it comes out as text, and it's nice, sort of, it's courier. It looks like code. But this is a table. It's an HTML table that came out. So you kind of wonder, well, how did this piece of Python code output an HTML table? And so the answer is that when Jupyter tries to display an object, first it checks if that object has a special method, underscore repr underscore HTML underscore. And if that method is present, it calls that method and interprets the output as HTML. So let me just give you like a 2-line example of that. If I define a new class called thing, and it has a method repr HTML, which outputs some HTML in triple quotes. I instantiate an object of that class, and then I leave it as the last thing in the cell, which means I'd like IPython Notebook Jupyter to display it. There you go. So this is essentially how you can hook into the smart display system of Jupyter to dump HTML into it. So this is the sort of second big idea behind this talk, and the thing that gets me kind of excited about Jupyter, because it means you can hack it in all sorts of neat ways, is that you can use this special method to hack sort of the notebook output. So there's one very obvious way in which Jupyter allows you to do this, is matplotlib. There's a special matplotlib cell magic, which when I execute it, matplotlib inline basically says, hey, from now on, matplotlib, anytime you're about to display something, why don't you just give me an HTML tag with a bunch of data as a data URI in the image source, and just so it'll just show up in my browser. So I'm going to show that off by running a little statement here, select star from hockey where country equals Canada. I'm also going to show you that for a line magic, so for anything that starts with a single % sign, you can capture the output and assign it to a variable. So here I'm going to assign the output of this to a variable called data, and I'm going to call a special method on it called pie, and I'm going to get this little pie chart, which seems to indicate that Montreal, which is where I'm from now, has won a lot more Stanley Cups than the Toronto Maple Leafs, which is shocking, but turns out to be the case. It almost looks like a little Pac-Man just eating the Toronto Maple Leafs. So it turns out that once you've executed matplotlib inline, this works for any code which talks to matplotlib. So this is not a very pretty graph. It's kind of the default pie chart that gets outputted by the SQL magic system. But if I import any other library like Seaborn, which is a really beautiful, has some beautiful defaults for matplotlib, and I get it to sort of do the typical sort of show off. I'm going to show the iris data set. You can get some nice stuff right here in the browser. So if you've ever done any interactive data analysis, this is really cool, right? Like you can have some data, you can plot it, and then you can go back up and be like, oh, what if I wanted to do this thing? You type and you hit Shift Enter again, and you get your new image shows up. So you don't have to mess around with having a shell and having to remember like when you SSH into a server, you got to use like the -X option, so it comes up in an X Windows window that you got to close and stuff. It's just sort of all inline for you right here. So this is why essentially most of the people doing data analysis in Python nowadays are doing it in IPython Notebook, partly because you can get stuff displayed either in a tabular form or in a graphical form, sort of inline with what you're doing. So this is already pretty exciting. And all that's happening here essentially is matplotlib is giving you an HTML tag and Jupyter is rendering it. That's the only sort of magic under the hood here. So I'm going to do a small plug here. Although I am a Python developer, I also work in JavaScript. I'm the author of a library called pivottable.js and the associated pivottable.js Python module. So I'm going to show you how you can actually do interactive JavaScript data visualization in a Jupyter notebook just by hacking this. So if I load up pandas and I'm going to read a CSV file, this is my sort of standard demo CSV, which I haven't had a chance to update. It's Canadian MPs from the last election. So I got to update this because we had some much better results this year. So if I execute this cell here, I'm just going to load up the CSV, and I'm going to show you the top sort of 5 rows. You've got the name of the NP, their party, their province, their age, and their gender. And so I'm going to show you how you make a pivot table. Normally in pandas, you can kind of have to type out this whole function here, and it'll give you, like an HTML table. This is all fine and good. If you want to change it, you want to sort of like pivot it, you got to go edit this code. Well, with a sort of JavaScript interactive system, if you want to just load up a pivot UI, a couple lines of code, the pivot UI function here will return essentially a whole bunch of HTML which will get rendered in your browser, and it looks like this. So now this is an interactive pivot table. You can sort of drag and drop and build whatever kind of visualization you want of your data set inline. So if you want to make a bar chart, boom, you got your bar chart. It looks a little bit better with a wider screen. You have to take my word for it. But so essentially, just by hacking this one little thing, which means I can output sort of arbitrary HTML into Jupyter, I've built myself an interactive data analysis tool right here in line with my Python code. So this is pretty cool, right? This is kind of starting to feel a little bit more magical. So has anybody here ever worked with Graphviz or the dot graph visualization language? OK, so normally the way you work with that is you sort of like type out a file, you save the file, then you go to command line, and you have to type dot and remember all the options, and it creates a file for you, and then you have to open it. OK, well, with the magic system, the special magic system called hierarchy magic, which I'm going to load, it's already loaded, I can now create special cells, %% dot, and the rest of this cell will be interpreted as a program in the dot language, or essentially as a graph, and it's going to get rendered inline right here. So, boom, I got my graph right here. So if, I basically implicitly said there's a node called hello, which has a directed edge to a node called world, and so on and so on, and I can add, sort of world on fire, Shift-Enter, and now I've got my new graph. So if you want to start like quickly making graphs, this is pretty cool. And this is already way faster than editing a text file, hitting save, running a command, opening it up, right? Like the iteration loop is way, way faster. And it's in the same tool that you're using to run Python code, connect to your SQL database, make some nice graphs. OK, so my excitement's starting to get a little, So finally, this is not strictly cell magics, but it's a cool feature of IPython Notebook that I want to show you, interactive forms. So if I load up this special decorator function called interact from the IPyWidgets module, I can essentially decorate any function. So let me show you how this works here. I've got this function called echo, and it's got an argument input whose default value is hello world, and an argument times whose default value is this sort of funky array. And all it does is it prints out the output, or it returns the output a number of times. The way Jupyter has interpreted this is it's actually built for me a little form just by essentially adding this decorator onto this function. What it does is it just re-executes this function every time I change the form. So I can actually sort of like change the number of times interactively this is getting outputted. Hello world, hello world, hello world. And as I type here, hello, Nick, and friends. This is pretty cool, right? You can build a form right in your IPython notebook. And it turns out that you can use this in conjunction with the matplotlib stuff I showed you a second ago to do this here. So here, all I'm doing is I'm doing sort of a hypothetical version of my pie chart here where like the Maple Leafs have not completely, the Canadians have not completely dominated the Maple Leafs in Stanley Cup wins. So you can run sort of, what would happen? What would the graph look like if the Leafs had won more Stanley Cups than the Montreal Canadiens? So what's actually happening here is every time that the slider moves an increment, a new PNG is being generated, and new PNG is being sort of overwritten directly in my browser. This is not interactive JavaScript. This is like machine gun PNG generation, but it's really cool. When you're doing some kind of simulation or you're doing some kind of data analysis, and you want to see what would it look like if that parameter was a little bit different, forget sort of edit the code, Shift-Enter, edit the code, Shift-Enter. You can just sort of like tweak it directly inline, and we use this all the time to do data analysis, sort of tweak various variables and stuff. So this is really, really powerful stuff, all right here in the same sort of tool chain as just execute the Python code. So that gives you a taste of just some of the cool things you can do with Jupyter. But the premise of this talk is essentially that I was going to show you how to make your own magic extension, just to show you that not only is it really cool, but it's actually really easy to do. So at work, basically what we ship is a web service, and we wanted to see if we could use Jupyter to build essentially an interface for our web service. So what I really wanted was essentially I wanted an HTTP client right here in Jupyter. And there isn't a sort of publicly available cell magic for HTTP. And maybe someday I'll generalize what I'm about to show you and sort of open source it. But I'm going to show you how to make essentially your own extension right here. I'm not going to live code it, but almost. So first things first, I'm going to switch out of the actual notebook view into Jupyter's built-in text editor. Oh yeah, Jupyter has a built-in text editor. So you don't actually really need to run a separate sort of program just for that. It's all in your browser. So here's essentially the contents of my directory where I'm running this from. I just say new text file, and bam, I got my text editor. So I'm going to call this samplex.py. Save that. I'm going to make sure that I'm in Sublime Text key mode. You've got Vim if you like. So here I've just created a file. Command S works. I can go back here. What I did was actually, you don't have to watch me type a whole bunch of code. I sort of grabbed a bunch of code that I can paste to build up this little extension. So here's essentially, and it picked up, syntax highlighting. Yeah. It picked up essentially, what I'm going to do here is I'm just going to define an extension I'm going to load from the browser. So pretty simple. You've just got to implement a method load IPython extension and call this special function register magic. So what I'm going to do is I'm going to say that for a magic called HTTP, I'm going to register this dispatcher function, which is right up here. And today all it's going to do is it's going to print a line. So save that, go back to my notebook. I'm going to load my extension. It's already loaded. Actually do this time need to hit reload. And so now if I sort of type, %HTTP blah blah, well, all it does is print blah blah. So good job, Nick. You've just re-implemented hello world again. But now let's build this up. So what we really want here is we want to be able to do sort of HTTP, get, and then something here. So I'm still running my local host on my sort of echo server. So what I want to do is to be able to actually type, HTTP commands here, have them execute, and see the output right here in my output cell. So in order to do that, all I really need to do is fill in this little dispatcher method here, right? So I've conveniently written all of that already, so you don't have to watch me do it. So I'm going to fill in my dispatcher function. I mean, essentially, all it's going to do is it's going to very quickly parse the line because the line is the input of this cell magic. And if it's a get, I'm going to do a get using the request library. If it's a delete, I'm going to do delete. And I'm going to parse essentially the remainder of the line after the URI as some sort of input. So let's save that. Go back to my magic. And this time, oops, I got to reload it, obviously. Reload. This time, ta-da! It says response 200. Okay, so I've actually, I've executed some sort of HTTP request and it's giving me response 200. Why am I not seeing anything cool here? Well, because in my extension, all I'm doing here when I'm executing get is I'm returning the output of requests, right? Which is a response object, and the response object doesn't have my fancy repr HTML method, so it's just using the default, underscore repr, which in the case of a request's response object is just the return code. So what I'm going to do is I'm going to use this little thing that I've already written, which is essentially a decorator on top of my dispatcher method, which allows me to decorate it and sort of pretty print the output. So that's what I'm going to do. I'm going to decorate the response of the dispatcher. And all that does is if it happens to be a valid request response object, it's going to add this repr HTML method, which Jupyter will call to sort of pretty print. So loadExt sample ext, and now, ta-da, I've got sort of color-coded output. It's showing me my my return code, and so the HTTP bin server that I'm running has all sorts of funny options. So if I do this, status 400, it's going to show me 400 bad requests. If I say 418, it's going to say HTTP 418, I am a teapot. And you can put, right? If I put to /put, and I'm going to give it some JSON, so A, B, then this is executed to put, and what this echo server is telling me is that the JSON that you put, well, I'm going to give it back to you to sort of test that it works. So that's all you really need to do to build a Jupyter cell magic. I've just essentially extended Jupyter for my own purposes. So you can imagine that any kind of service that you are interacting with, that you want something that's more terse than actual, full-on Python code with all the quotes and everything that you're going to need, you could build yourself a cell magic extension for. People have kind of gone a little bit wild with this stuff, building all sorts of extensions like I've shown you for SQL and various graphic backends. I'm surprised there isn't one for Git yet, or at least not one that I found, but it seems like an obvious kind of extension. HTTP would be nice to have a sort of fully featured HTTP client. But that's basically the cell magic system. So just to recap, I've shown you that you execute Python code, you can write Markdown cells, you can also execute Bash code, you can execute SQL commands, you can execute HTTP commands, you can draw graphs, you can draw the other kind of graph, like directed graphs. You can make interactive data exploration tools available right in the notebook. You can actually code Python. You can write Python files right from Jupyter. So I hope I've gotten you guys a little bit excited about this tool. I've got sort of one more thing. Any notebook like this one can be served up as a slide deck really quite easily. So the first thing you need to do here is going to toggle the toolbar. So when you've got the toolbar active in Jupyter, you can see that there's this little cell toolbar here. If you turn this to slideshow, you can essentially control for any given slide how it will be outputted when you output it to a slideshow. So I've already annotated this whole notebook, so you don't have to watch me do it. But basically, I can just grab this little command line command, switch over into my. It's already here in a shell. I run this. So I said you could run bash commands in IPython Notebook. You can, but long-running processes like this one, it's not very good. Like it's good for interactive type work. But essentially, this exact notebook that you saw me sort of scrolling through and executing code dynamically is now a nice little slideshow, nicely formatted. You can scroll. It's got sort of everything. It's got the output, and it's even got the graphs. Right here, inline. So you can take this, and it's one HTML file. You can email it to someone. You can stick it on GitHub. It's pretty neat. So some of the speakers at this conference already have used this system, and it's great. It's really awesome. You even get a little progress bar. I don't know if you guys can see the top few pixels here are like a progress bar for my presentation. And speaking of, and this is sort of normal Reveal.js type magic. And then speaking of hosting this stuff, this, gotta get rid of this here. This notebook is available on GitHub. And if you actually go to this link here in a new window, you will see that, GitHub will actually, any Jupyter notebook that's sitting in GitHub, GitHub will render for you in the GitHub web UI. So you can actually just like scroll through this thing and read it without actually having to download Jupyter and run it yourself. So that's basically the end of my talk. I'm happy to take any questions, and I'm easily reachable in any of the ways that are available here on the screen.
If you have any questions, please line up here at the mic.
Yep.
So you say you package this as part of your product. Is there a security built in, like is this available on EPAD, or do you CDN into it, or how do you manage that?
So IPython Notebook, or sorry, Jupyter is essentially a giant security hole. Just to be clear, not only can you execute arbitrary Python code, but it actually comes with a web-based terminal, which is really convenient when you're new terminal. So you can literally have like a shell here. So there's nothing built into Jupyter other than a basic password system, as far as I know. The way we do it is that we only bind to a local port, and we require you to SSH tunnel into the server. So in terms of like the way we use it, we've just punted on that and said it doesn't bind to a local port, to a public port. And in general, it's something that needs to be, you need to be aware of when you're running a local web server that allows you to run arbitrary code. Just sort of be aware of what you're doing.
I'm sorry, Nick, could you repeat the question they asked so we can record it?
Sorry, the original question was, what about security, basically?
Yeah. Over there?
Yeah, I just wanted to know if you knew of a way to hide or lock the code part of IPython Notebook or Jupyter for potential business users, basically to use IPython Notebooks as a reporting tool.
There is no built-in feature for that, and you should email the organizers. Sorry, the question was, is there any way to sort of hide or lock the code output for business users? So there's no feature in Jupyter for that, and you can email the developers to ask them why that is. There are a bunch of different ways to do that. I have like a special JavaScript snippet that'll essentially hide the code when you export it to HTML, but there's no built-in way to do that. So when you do the slides, essentially, you can't just show the output of a graph. You have to show the code that generates it. Was this all like new to you guys, or is this all like old hat and you were bored by my presentation? New? Okay, old hat, new everything? Okay, good.
Okay, here.
I'll be around for the rest of the conference if you guys want to ask me any questions or want more demos or something like that.
Do you know of any extension or magic that does interface with WebGL?
With WebGL? There are products that essentially exploit WebGL in their output, I believe. Graphistry is one, which does sort of high-performance graph visualization, but there's no sort of general-purpose WebGL cell magic, although as I've shown you, it's fairly straightforward to write one. If that answers your question.
Okay, we have time for one more question. Anyone? Okay, I guess that's all the time we have for this talk.
Thank you very much.
Okay.